right? It's just before the ball touches this surface and just after this ball rises up. Understood? We have to find the change in momentum. But for that we need the velocity v1 and v2. If anyone doesn't know how to do free fall, pay attention, okay? First we fix a convention. Let's fix the convention for when a ball comes from here to here. Understood? When it falls down. Let's fix a convention. Let's take downwards positive or negative? Huh?
Negative.
Let's take it positive. You know why? Because everything is downwards. This velocity is also downwards. G is also downwards. Displacement is also downwards. Understood? So let's take downwards positive. Once we take downwards positive, can I write which equation should I use? V square minus U square is equal to 2AS. 2GS, okay? 2GS. Understood? V we have to find. What is initial velocity?
0.
This is 0. So V we will get 2. What is G? 10. Plus 10 or minus 10? Plus 10. Why? Downwards. Understood? So we will take it plus 10 and displacement plus 5 or minus 5? Plus 5. Okay? 5. So how much we got? 100, right? Understood? So how much is the V? 10 meters per second. We got 10 meters per second downwards. 10 meters per second downwards. Understood? Let's calculate V2 now. Let's calculate V2 now. Calculating V2, how do we calculate V2? Now let's consider from here to here. Okay? Let's consider the motion from V2 here to final velocity 0. Right? Can we again use V square minus U square equal to 2AS? Because we have been given final velocity, we have been given the displacement. Can we calculate? Let's take upwards positive or negative?
Negative.
Negative we can take upwards or we can take positive also upwards. Let's take negative for now. Okay? Upwards negative. Because downwards positive we already fixed the convention. Let's do it here. Can I use V squared minus U squared is equal to 2GS? Here initial velocity is 0, final velocity is 0. Here initial velocity is 0, final velocity is 0. Final velocity, right? So final velocity is 0. This one was V1, right? V1. Final velocity is 0. Initial velocity V2, right? V2. We can name it as V2. V2 square is equal to 2 into G. G, what is the value of G? Negative 10 or positive 10? Negative 10 or positive 10?
Upwards is negative.
We are going upwards, but G is continuously acting downwards.
What? But
Sir, but
Acceleration due to gravity is downwards or upwards?
sir, downwards, but with respect to the ball, sir.
With respect to ball also. See,
no,
ball
but it's
is
moving upwards,
it's
yes.
moving upwards, but why is acceleration acting? Why is the force of gravity acting?
So displacement.
Always downwards.
But doesn't it reduce like when the ball is thrown up or something?
It reduces the velocity. That's what it
So
does.
isn't it negative?
Listen to me.
I
Velocity.
didn't get the word.
Displacement.
Ball is going upwards.
Yeah.
Okay, ball is going upwards with velocity of v2.
Yeah.
Okay. After some time, this ball stops, right?
Yeah.
And its final velocity is how much? 0. Clear? See, force of gravity is acting downwards, mg. So g is also acting downwards, always downwards. That's why due to this force, the velocity v2 continuously decreases and becomes 0. What's making this velocity to 0? Force of gravity. Understood? There is one force acting continuously downwards. That's why this velocity is continuously decreasing. And in this situation, the velocity is continuously increasing. Why velocity is increasing? Because force is acting downwards. Always, g is always downwards. Understood? Now, did we take downwards positive or negative?
Positive.
Positive. So we will take g as positive 10. Understood? Now is the displacement. See, displacement is from initial point to final point. Displacement is upwards or downwards? Upwards. Here displacement upwards or downwards? Downwards. So here we will take displacement. How much displacement we have?
Minus.
3.2.
3.2. Should we take minus 3.2 or plus 3.2?
Minus.
Downwards we took positive, upwards is negative, we will take it minus. Understood now? Understood, that's why convention is very important. Convention is very, very important. Clear? Clear? So this minus and this minus gone. Is it gone?
Yeah.
So how much we will get V2? How much we will get V2?
8 meters.
You got 8 meter per second?
Yeah.
You got 8 meters per second? 64? Yes, 8. 8 meters per second. 8 meters per second upwards or downwards? Upwards. 8 meters per second upwards. Understood? Is it clear to you? Here, this 10 meters per second downwards or upwards?
So according
Downwards.
to free fall also G is taken as minus when plus when it's thrown up.
What?
According to free fall, when a ball is thrown up, G is taken as positive there also.
If you have taken convention, we have taken convention, right? If you have taken convention downwards positive, then it will be positive. Understood? It will be always positive. If we take convention downwards positive, it will be always positive. Understood? This is up to us, right? Downwards we took positive. If I take negative, no problem. Then here G will be positive. Understood? It depends on us. The convention depends on us. Whatever we feel easy, we will take that convention. But according to that convention, we have to fix. We have to put every vector in the form of whatever convention we have decided. Is it clear to you? Is it clear to you now? No doubt? No doubt? So G always acts upwards or downwards? Downwards. Always downwards. Retardation. See, here it's acceleration from here to here. Here it's retardation. Understood? When do I have retardation? When the acceleration is opposite to the direction of velocity. If a car is moving frontwards, acceleration is backwards, that means it's retardation. Right? In a similar way, ball is moving upwards, but acceleration is downwards. It's retardation or acceleration? Retardation. Here, ball is moving downwards, acceleration is downwards. It's accelerating or decelerating? Accelerating. If I drop this pen, it's accelerating or decelerating? Accelerating. If I throw it upwards, accelerating or decelerating? Decelerating. Understood? Now, no doubt. No, if you have slight doubt, just ask me. You have slight doubt now. We got it. Did we get the velocity v1, v2? Now let's find change in momentum. Let's find change in momentum. Why do we need to find change in momentum? Already I told you the average force or net force is equal to the change in momentum, finite change in momentum divided by finite change in time. Can we calculate delta P? Can we calculate delta P? Look at the board now. In this small interval of time, when this ball was just about to hit this floor, it came down, it went up. There will be change in momentum, right? In what amount of time? In this small amount of time, there will be force, right? I told you, right? And this force will be high value. Why? The time interval is very small and the change in momentum is high. Understood? Comparatively high. Understood? Let's calculate change in momentum. Can we calculate change in momentum? Don't do M1 U1. Huh? Just go according to the concept. Don't remember formulas in physics. Don't remember formulas. Whenever your concept is clear, it will be easy for you. Okay? So let's start with change in momentum. Change in momentum is equal to final momentum minus initial momentum. Final momentum minus initial momentum. Is momentum vector quantity or scalar quantity? Vector. Can we add them like apples? Can we separate them like apples? No. We cannot, because it's a vector quantity. We cannot add or subtract vectors like scalars. Understood? So we have to follow the convention. Let's follow the convention step by step. Easy. Okay? Final momentum. Tell me what is the final momentum. This is final. Finally, right? Finally, what is the mass? 50. What is the velocity?
8.
Right? Can I write 50 into 8? Can I write 50 into? Can I write mvf minus v initial? Mass is constant, right? Mass is constant. So how much is mass? 50. How much is v final?
8.
How much is v final?
8.
8. Can I write 8? Velocity is vector quantity or scalar quantity?
Vector.
Is mass vector or scalar? Scalar. So no need for direction. Okay. Here we need direction. Can I write it like either I take plus or minus sign like we took here, or else I will take it I cap j cap. Let's do it I cap j cap here. Okay. In which direction is this 8? J cap upwards, right?
Yeah.
Remember upwards j cap. Right side I cap. X axis I cap. Y axis j cap. Negative x y axis minus j cap. Negative x axis minus I cap. Outside z axis k cap. Negative z axis minus. Let's take it 8 j cap. 8 j cap minus, right? Formula minus. Okay, formula minus. What is V initial?
10.
10. What is the direction?
Positive J. Negative J.
Negative j cap. Negative j cap. Okay. If we have subtracted them like we subtract vectors, we would have got 2, right? 8 minus 5, 10, 2, right? But we cannot do that. So we have to take the consideration of direction as well. Okay. So 8 plus 10, right? How much we got? 18 into 50. How much we got?
900.
Huh?
900.
900. 900, right? This is our momentum, right? Kg meter per second. In which direction? Upwards or downwards? In which direction? This is j cap, right?
Minus
J cap. No, j cap, right? So it will be upwards. Understood? It will be upwards. Change in momentum also is vector quantity, right? So this change in momentum will be upwards. Understood? Now let's calculate net force. Now easy? Okay. Can we calculate net force? So net force will be equal to, or the average force will be equal to how much? Change in momentum divided by small time, change in time. What is change in momentum? 900. 900 j cap. Let's put the j cap also. Okay. Divided by time. Time scalar or vector?
Scalar.
Scalar. So how much is the time?
0.02.
0.02. So how much you got the answer? Huh? 45,000 j cap. Why j cap? Because force is also upwards now. Net force is upwards. Okay. Net force is upwards. Is it clear? Is this question clear to you? Understood? Any doubt? Any doubt here? Write this question. Did you write the question? Write the answer.